Don't know the answer? Ask the Naked Scientists.
Hello and welcome to this week's Ask the Naked Scientist with me, Sue Marchant, and Dave Ansell. It's Dr. Dave, our regular Naked Scientist, and Dr. Dom, who is here to join us. Good evening, gentlemen.
Hi,
Good
Sue.
evening.
It's great to have you here on the show once again, and welcome back, Dr. Dom. Now, what about any sciencey, exciting news that's going on?
I saw an interesting story here. A company called Alcatel-Lucent has just come up with a way of speeding up your broadband a bit. Now, normally broadband into houses is maybe up to about 10 megabits. That's 10 million ones or zeros every second going into your house. They think they've got a way of getting up to about 300 million just using copper without any of this funky fibre optic and sending it through light, just by electric signals down copper.
Which is quite basic stuff, really, isn't it?
Yeah, I mean, it's fairly standard. They reckon they can get it on the normal phone line, so in your house. It's probably going to take them a while. They've been doing all sorts of cunning things. Some of them which are already being done already. They have this cunning thing whereby, because with lots of wires when you send signals down a wire, the signal gets picked up by the other wires in the bundle. So a bit of that signal gets picked up in the other wires in the bundle, and that causes interference and it confuses your detector at the other end. So one thing which they've been doing is sending the sort of reverse. They know how much of this crosstalk it's going to produce, and they sort of they reverse it. So they send signal down both wires, one the right one and one to cancel out the crosstalk which is going to be produced. So that's one thing. And they're also if you've got like half a dozen wires in your bundle of wires into your house, instead of just sending the signal down one wire and it coming back a second wire, they send it down all 6 wires. So you've got a bundle which will send maybe a whole lot of information, one pair which will send one lot of information, another pair which will send another lot of information. You can actually send the signal between the pairs as well. So using 4 wires, you can get 3 sets of information down the wire, and using tricks like that, we're getting up to about 300 megabits per second, which is impressive.
This one comes by email, and it's about the Hadron Collider. Mark is asking, has it got any other purpose in its life than what it's supposed to sort out about the Big Bang Theory? Can it be used, for instance, for any other everyday experiments in this field? Dave?
They're trying to find out a couple of things with the LHC. One of them is they're trying to find the particle which they think gives things a mass, gives things inertia. So if you ever notice trying to push a heavy shopping trolley, the way it's very hard to accelerate it, and once it gets moving, it doesn't want to slow down. At the moment, we don't have a theory which really explains why that happens. All we know is this is just a property of the universe. And there are some theories which think this is due to a particle called the Higgs boson. But no one's ever found this, so they don't know whether it exists, so it might be entirely wrong. So one of the things the LHC is doing is trying to find the Higgs boson. I think another thing they're trying to do is there's a theory there's various really fundamental particles. The ones which you've probably heard of are things like electrons, protons and neutrons. Protons and neutrons are made up of things called quarks. And there's a load of other more exotic particles as well. And there's theories as to why these particles exist and what they are. And if these theories are right, there should be a load of other particles called supersymmetric particles which are related to them. And they're trying to find these with the LHC. But as for every day, trying to find out something useful which might make your toaster more efficient or your car go faster or your computer go faster, probably not, except possibly as a byproduct. Because whenever you try and do something really, really difficult, you find you've got to invent new technologies, and you suddenly discover these new technologies are useful for something else. The thing before the LHC, some guys who were kicking around, they had lots of information which they wanted to transmit between people, and lots of documents and things, and they thought, wouldn't it be useful if you could click on bits of a document in order to get to another document somewhere else in the world attached to this thing called the internet, which was relatively new at the time. And basically this is what turned into the web. And so no one would have thought that building a particle accelerator would get you a means of ordering a pizza remotely. But these things, you never know what's going to happen with technology.
Never know how hungry you are either, Dave, do we? Thank you for that. Let's head on to one now from Dave in Great Yarmouth, actually. Now, this is looking upwards, so it's in your department, Dr. Dom. He's been looking at the Viking 1 pictures of Phobos, the Mars moon, and its very enormous crater. Surely, if it had been impacted by another body, wouldn't it have been obliterated?
Yes, well, when meteors hit objects in space, these can produce very violent results. They can completely obliterate planets. In fact, between the planets Mars and Jupiter, there's a belt which we call the asteroid belt, which is filled up with little fragments of rock. It's quite possible, actually, that Phobos originated as a fragment in that asteroid belt. And we think that that formed when perhaps two planets collided, slammed into one another, and just obliterated each other. So it's certainly possible that a collision can blow something apart. Obviously, meteors are usually rather smaller than that, and they just produce craters on the surface, as, for example, you see on the Moon. So it's all about how big the impacting object is, what result it produces. And clearly Phobos is still there, so it just about survived that collision, but it may have been quite unpleasant at the time.
All right, let's go to our next one here. It's also, I believe, in your department. Mike in Colchester would like to know, the Hubble telescope. Is it just like a normal telescope with reflecting mirrors, or is it something a little bit more magical? What's special about it?
Well, of course, this month we should be celebrating Hubble's 20th birthday. It's 20 years old this month.
Really? 20 years old?
It's 20 years old. It started in 1990, believe it
Wow.
or not. But there's nothing magical about it. It's just a fairly ordinary reflecting telescope with a mirror that's a couple of metres across. There are actually much bigger telescopes on the surface of the Earth. But the reason why Hubble is so special is because it's in space. Now, if you look up at the night sky, you've probably seen the stars twinkling, and they don't look like points of light. They look like they're kind of moving around, jostling about. And the reason for that is because of the Earth's atmosphere, which is full of turbulent gas, air at different temperatures mixing and producing turbulence and distorting the image that you see, just like if you look through the smoke coming out of a kettle, steam I should say, coming out of a kettle, then you see this sort of shimmering effect. And that's a real problem for astronomers, because it means that you can't see really fine details on the sky from the Earth, because it's lost in that shimmering. Whereas because the Hubble telescope is above that, it doesn't have that distortion. It can pick out fine details that you just can't see with terrestrial telescopes.
I guess the other thing is you can see colours of light which you can't see with terrestrial telescopes. The ozone layer is up there in the sky, which is great for us because it stops us getting nearly as badly sunburned as it would be if it wasn't there, because it blocks out the ultraviolet light. If you're an astronomer and you want to look at things in the ultraviolet light, you can't see through it. If you can get up above it, then you can see beautifully in the ultraviolet.
Yes, and that's really important for understanding massive stars which put out a lot of energy in the ultraviolet, which you just can't see from the Earth.
All right, well, this brings us very nicely to a question that Mike in Colchester has put. Outer space must be full of the equivalent of this volcanic ash now. How does it affect space travel, after all? And how does it affect seeing, further out there? What's happening? Have you seen all this ash through a big telescope?
Yes, well, there are a lot of bodies in the solar system which are volcanic. One which I'm particularly enthusiastic about is Saturn's moon Enceladus, which has a cryovolcano at its south pole, which is spewing out little crystals of ice. And because Enceladus doesn't have a very strong gravitational field, rather than forming a plume in the atmosphere of Enceladus, it doesn't have an atmosphere, that volcanic ice is just lost to space, and it ends up orbiting around Saturn. And we think that those ice crystals are feeding into Saturn's rings, and perhaps explain why Saturn has this magnificent ring system that you can see through telescopes. So often, particularly on moons that don't have much gravity, ash clouds like what's been blowing over Britain this week are just lost to space, and they end up becoming sort of space junk, filling up the voids between planets and stars.
I mean, it is a problem if you've got a space rocket or a satellite, because you get hit by lots of these tiny lumps of dust, and because in space there's no atmosphere, there's nothing to stop them going incredibly fast, so you can get little particles of dust moving at 40,000 miles an hour, and when they crash into your spaceship, it's very, very hard to protect against it. They're going to vaporise. They make little pits all over the spaceship, all over your solar panels, and so slowly things like solar panels get eroded by these little lumps of rock hitting them, and they get less and less efficient until eventually your spaceship is basically kind of pitted and stops working.
If you do a calculation of what you would need to destroy the International Space Station, it's actually really quite scary, because debris orbiting the Earth is going so incredibly fast that even something that's the size of a pebble could completely destroy the International Space Station because of the speed it would be travelling when it hit that satellite.
Right, let's go to this one. Paul has asked by email. He says, could a comet shield Earth from the sun? If you put a comet in the Sun-Earth L1 point, would the comet cloud tail shield us from the sun and cool the Earth? That's a good question.
Well, of course, when you think of comets, what you imagine are objects in the sky with these magnificent tails coming out that you can see streaking across the sky. And what happens when a comet ventures near the sun is that because the object is made of a mixture of gritty, dusty material and a sort of snow-like material, that snow starts to melt, or in fact sublime, which is to go straight from the solid state to a gaseous state. And once it becomes steam, it's no longer bound to the comet and just drifts off into space, and it's blown away from the sun, and it forms this magnificent tail that we see in the sky. Now, I think what the questioner is asking is if you had a tail and you managed to keep the Earth in that tail, whether that might shield some of the sunlight from the Earth and perhaps be a way of remedying global warming. And I think, theoretically, if you could put a comet between the Earth and the sun, then being in the tail of that comet would dim the sun's light and it would cool the Earth. I think the technical challenges of putting a comet between the sun and the Earth would be quite difficult. I don't think we have the technology to do that just yet.
I think it would be easier to send up rather than trying to capture a comet which is already up there. It would be easier to send the stuff up in space rockets. And people have suggested doing this. But I guess the dangerous thing is that it would probably stay up there quite a long time. And if for some reason you wanted to get rid of it afterwards, then it'd be a much bigger job to get rid of all this dust sitting up there, shadowing the Earth. If all of a sudden the Earth went into an ice age or something, and getting rid of it would be a right nightmare.
All right, one more here. I don't know whether you're going to know the answer to this. Lisa says, why isn't there a cure for colds?
I think the main problem is that, for starters, lots and lots of different types of colds, and they evolve very quickly. Basically, they're quite unstable things, and they keep changing all the time. And the ones which your body can fight just get killed off and get stopped, but the ones which your body can't fight get amplified in your body. Your body is used to copy lots of these viruses, and they go out and they infect other people. And so there's a really strong evolutionary pressure for colds to keep changing until they can get round your body's defences. And then your body's defences adapts and learn how to deal with that cold, at which point there's another cold which is evolving in someone else, which means that you can catch them again. So yes, it's because they keep changing and they're very, very unstable and they keep evolving around your body's defences.
If you're enjoying Ask the Naked Scientist, then you might like to check out The Naked Scientist, our regular roundup of the world's best science. Each week we take a look at the latest science news, talk to top researchers working at the coalface of discovery, and also get our hands dirty with a science experiment that you can join in with too. So make it a date and prepare to strip down science on the web at nakedscientist.com/podcast. Jean in Holbridge has sent a question in. She said, do you think there'll be a possibility of a vaccine or immunisation to developing cancer?
Cancer is basically some of your own cells which have started multiplying and multiplying and multiplying. Normally there's lots of systems in your cells to stop them going out of control, and if they get in the wrong place they commit suicide basically, and if they get too old or damaged they commit suicide. But sometimes those systems are damaged themselves, and so the cells will just keep on multiplying, multiplying and multiplying. We call it cancer. There are already things, essentially vaccines. Herceptin is one of them, which basically gives you immunity to one type of cancer. The problem is there's many, many different ways in which your cells can go wrong, so they keep multiplying. And different types of cells will behave slightly differently, and they give off different proteins on the surface which your immune system can attack. Most cancers your immune system attacks already, so you're already trying to get ones which are difficult for your immune system to catch. And so I don't think there's going to be one immunisation against cancer. And also there are some cancers which are created by viruses in the first place. So things like cervical cancer quite often is caused by a virus which comes in and does the damage by a virus getting into the cell and copying itself, and that has a side effect of making some cells go wrong and start multiplying. So you can certainly immunise against the viruses which create some cancers, and you can create basically vaccines or drugs which will cause your immune system to attack certain cancers, but there's probably hundreds of different cancers, and we're only right at the beginning of learning what different cancers there are. But yeah, if you give it long enough, possibly quite a lot of them we will be able to.
Our next question comes in from email from Robbie Shaw, and he asks, Earth has a certain temperature as heat flows from the sun as means of radiation. So what is the temperature of the vacuum through which the heat is radiated? So what is the temperature of space between Earth and sun?
Well, if we start at the sun and move outwards, the surface of the sun itself is at about 6,000 degrees C. And just above that you have a layer which we call the corona, which you can only see during solar eclipses when the moon blocks out the main glow of the disk of the sun, and you can see this sort of halo around it. And that we think is very much hotter at several million degrees C. And it's actually a real puzzle as to why this layer of gas immediately around the sun is at millions of degrees as compared to the surface of the sun, which is so much cooler. We don't really understand why, but we think perhaps there are sound waves in the sun which are sort of knocking against this gas which is just around the sun, and this friction is really heating up this gas to tremendous temperatures. Now, above that, you have gas which the sun is continuously venting out into space. Because the sun is a kind of boiling ball of gas, every now and then this gas is sort of boiling off, and it just flows out of the solar system in a flow that we call the solar wind. And that is similar material to the corona at really quite scarily hot temperatures, millions of degrees. But luckily there's not very much of it, so it doesn't burn the Earth. Now, the way in which the sun behaves is really quite variable. It can sit there being quiet, not really bubbling off very much gas, and then suddenly it can undergo an instability that we call a coronal mass ejection, where for some reason the magnetic fields in the sun essentially get out of control, and a pocket of gas about the size of the Earth is often thrown off. So a huge amount of gas is blown off out into the solar system. We're quite lucky on the Earth because we have a magnetic field that shields us from those fireballs, so we don't get hit by them. All we see is a very dramatic display of the northern lights when they hit the Earth. Other planets are less lucky.
I mean, I guess in some senses the temperature isn't very well defined, because normally if you say an area is at a certain temperature, everything inside it is at about that sort of temperature. But because the space between the Earth and the Sun, things don't interact very well. So if you've got an asteroid sitting in there, or a comet, then the temperature of that comet, even if it's sitting there all the time, is going to be very different to the gas given off by the sun, because the comet can radiate into all the colds, it can emit heat radiation and lose heat quite efficiently into all the cold stuff around it, into the cold space everywhere which isn't the sun. There are lots of things at lots of different temperatures, and there isn't really a temperature for the space in between.
Mark Smith has asked a question. We've got lots of Mikes and Marks this evening. My son and I have been getting interested in physics, and we're looking to start learning algebra to get more into it. So can the movement of electrons be harvested?
I think he's talking there about the fact that electrons are orbiting atoms all the time, and that seems like they're moving really fast, and they ought to have lots of kinetic energy, which maybe we can use somehow. The problem with this is that if the electrons are orbiting an atom and they're excited and they've got lots of extra energy, they're orbiting at a high level, then you can get that energy out. In fact, that energy is normally emitted spontaneously in the form of light. So if you give atoms lots of extra energy in, for example, a fluorescent tube above our heads, they then give that energy out as light, and then that's how you. Then that light's actually converted. Ultraviolet light's converted into visible light by some phosphor on the surface, and that's how fluorescent tubes work. And so you can get energy out of excited atoms. But if the atoms are cold, they haven't got very much energy. In fact, the electrons that have got the least energy they're allowed to have whilst being near an atom, the only way you could extract that kinetic energy would be able to take them away from the atom, and that would take far more energy than you get out from their kinetic energy. So the simple answer is no.
Right, let's go over to this one, an email that's come in from Derek. Now he says, I heard on the news that astronomers have discovered 9 new planets, and unlike the planets in our solar system, 2 of the newly discovered planets are orbiting in the opposite direction to the rotation of their host star. Does this discovery upset the primary theory of how planets are formed?
Well, you would normally expect in a solar system that the planets would all rotate in the same direction, and that would be the same direction which the star itself was rotating. You would expect that because we think that solar systems and stars form from common clouds of material, and that material will rotate either one way or the other, and that as the core of that cloud collapses down to form the star and the outer parts of that cloud form into planets, they would all be going round in the same direction. It's possible that a solar system could pick up a planet which is free floating from interstellar space. And the way that you can get these planets is that we normally think of planets just going around a star in orbit, and each one goes around in a circular orbit. But in fact, you have all sorts of really hideous gravitational interactions between the planets in solar systems. And for example, in our own solar system, there are lots of interactions that are going on between the planets which are actually gradually changing in their orbits, and we're very lucky that we live in a solar system which is quite stable. But potentially planets can just get kicked off out of a solar system if they get too close to another planet, and then that planet becomes a free floating rocky body which is just drifting between the stars in our galaxy. We think there's probably a huge number of these lonely planets out there with no stars, and then another star could pick up one of those planets and it could then start going around that star. So I would guess that if this star does have planets going the wrong way round, it's quite possible that these are lonely planets that this star has adopted.
Gordon Hatford, by emails, has said, why is the core of the Earth so hot?
Well, the Earth has various radioactive materials in it, like uranium, and of course we sometimes dig them up and put them in nuclear reactors in power stations, and they get hot in the power stations, and that's what powers things. But they sit there in the crust of the Earth, not really causing anyone any particular harm, because they're not in the kind of concentrations that you'd need to actually be a medical hazard. But they're sitting there sort of gently being warm, and all of the radioactive rock in the Earth is enough to produce quite a huge amount of energy, and that is keeping the centre of the Earth hot over periods of billions of years. And that is why, for example, when volcanoes erupt, the rock below is so very hot.
That's definitely a very large proportion of the heat in the Earth. I think still some of the heat is still left over from when the Earth was created, or very early in its billions of years ago, very early in its life, when it was formed by lots of lumps of rock crashing into each other. And as they fall into each other, there is a huge amount of gravitational energy, and that energy's got to go somewhere, and they get hot. And the Earth is just so big that it hasn't actually lost all of that heat yet. And some of the heat which is escaping the Earth at the moment, order of tens of percent, is still just the original primeval heat just getting released slowly.
Let's go to another one now. This is from Jacob, and he says, I'm 9 years old, and my question is, why isn't metal attracted to the Earth, being that it has a magnetic field?
You're right, the Earth is a great big magnet caused by movements of molten rock in the centre of the Earth. Metal, well, not necessarily all metals, magnetic metals, so things like iron, steel, nickel, cobalt, are attracted to the Earth. But the Earth isn't a very strong magnet, it's a very, very weak magnet, and so they're not attracted very strongly. If you can get a much stronger interaction by having a magnet, so if you have a small magnet hanging off a piece of string, it will always point north or south, depending on which way around you've got the magnet, and you've got a compass, and so because the magnet is already magnetised, that interaction is much, much stronger, and so you can actually see it. So they are attracted, it's just so small you can't really notice it.
All right, one here that's come from Carmen, who says, I went to see a 3D movie recently, and she said both myself and my partner came out after and felt very dizzy and disorientated, in fact almost to the point of feeling sick. Why is this? Is it just the goggles or the whole experience of the film?
I'm certainly not an expert on this, but I can guess what some of the issues are. Is that they're producing the 3D effect by putting a slightly different picture into your right eye than your left eye. Quite often they have things called polarizers, like Polaroid sunglasses, and light can have different polarizations, either horizontal and vertical, or in fact I think with those they have where the light is twisting clockwise and anti-clockwise, and the clockwise goes into one eye and anti-clockwise goes into the other, and so they can project two different images on the screen, and only one eye in your right eye sees one, your left eye sees the other. If you hold your finger up very close to you, and shut one eye then the other eye, you can see that your finger moves. It's an effect called parallax, because your two eyes are in different places. Things which are close to you look different from your two eyes, and then your brain can use that information to work out how far away they are. That's one of the ways you judge how far things are away. There are lots of others, things like if you move your head, then the thing which you're looking at will move as if you're shutting up one eye and opening the other eye. It's things to do with its shape and how they move. And I think probably part of the problem they might be having is that you've got some of the cues of something being very close to you, but if you wobble your head from side to side, it doesn't move like it should do if it was very close to you. So you're getting confused signals to your brain, and that can make you feel very uncomfortable sometimes. In a similar way that when you get confused signals, if you're sitting on a boat, which your ears think are moving, but your eyes doesn't think is moving because you're moving with it, then there's something in your brain which thinks there's something very wrong. Maybe I've eaten something bad, so maybe I'll throw up, because eating the wrong things can have that sort of effect on you sometimes. And so you feel seasick. So I'd have thought it's something a bit like feeling seasick, where you're getting kind of contradictory information into your brain.
This has come from Darren. I wish to know whether X-ray effects goggles are really available, and if so, do you know where they're sold?
I worry about why he wants the X-ray goggles slightly. Certainly not what you think of as X-ray goggles, which are working on X-rays. First of all, they're actually quite dangerous, because X-rays can give you cancer. If you get too much exposure to X-rays, it's not at all good for you. Secondly, all the X-rays that you see around the place in hospitals and things, they're actually a shadow picture. So you send X-rays, which are a form of light which goes straight to all the squishy bits of your body, but not the bones so well, from a transmitter, and then it's shone through your body, and then you have a sheet of film behind you. And then the pictures you see are actually the bones you see on the X-ray are actually shadows. And so X-ray goggles wouldn't really help. And you could build some goggles which are sensitive to X-rays, but you'd need to have a great big X-ray transmitter behind the thing you were trying to look at, and it wouldn't be very practical. Saying that, there are various kinds of light which can see through things differently to the way our eyes can, and will make some things look transparent. One which lots of people talk about are called terahertz radiation. It's a bit like very, very short microwaves, and they'll go quite easily through things which don't conduct electricity, things like clothes, but metal and your skin and your flesh conduct electricity well enough for them to be reflected or absorbed, and so you can see through some things. But they're very, very experimental and not very cheap, and you certainly can't pick them up and strap them to your head.
Also, Mark has called in to say, why are planets round?
It's all to do with gravity, which is pulling the planets together. And at each point on the surface of the planet, the gravity is pulling towards the centre of mass of that planet, which is in its centre. Now, if, for example, you had a cuboidal planet, which was in the shape of a cube, then the corners of that cube would be quite a long way from the centre of that cube. It's got to go diagonally through that cube. So that stuff at the top of that mountain on that corner can actually get closer to the centre by falling down onto the side of the cube. And that's going to be a state of lower energy. It's going to release gravitational energy when that rock falls down off that corner onto the face of the cube. And the rock will always try to move downwards under gravity to the lowest possible state, and that will be a sphere where the surface is always the same distance from the centre.
That's it for this week. Our doctors will be back with me next week for more Ask the Naked Scientist. But don't forget, you can also catch them on the Naked Scientist podcast, which you can find on the Naked Scientist website, www.nakedscientist.com.
The Naked Scientists are sponsored by the Wellcome Trust, the EPSRC and UK Fast. For more information, look us up online at nakedscientists.com.